Good afternoon, this is Paul Hornbeck with the EET4833 Team Aircraft to Naval, doing the project summary for the Mauser air-to-ground remote control. The objective of this is to enable a pilot to activate the landing lights on an unattended runway by using the microphone on his radio so that he can have some assistance in landing. Overview of the Mauser system: it's an economy type system, meaning it's cheaper than instrument landing systems used for smaller airports, but it's also a basic component in precision runway systems. The basic Mauser has three main components. It has a threshold bar, which is a row of lights at the end of the runway. It has 9 light bars, which are groups of 5 steady burning lights in a row that are placed in a pattern in front of there, as you can see on the slide. And then there are 5 sequenced flashing lights that will flash in sequence to kind of give an alignment view. They call it the rail, the runway alignment indicator lights, and they kind of move in sequence so that there's an appearance of motion towards the runway. The threshold bar, again, it's a variable number of lights that they'll color green, spaced across the end of the runway, and it just tells the pilot where the end of the runway is. You have 9 light bars. 7 of them are spaced every 200 feet along the runway center line. And then they're at the 1,000 foot line, or the 5th bar. We'll have three bars, with each. The side bars are spaced 28 feet to each side of the center line. The sequence flashing lamps, there's 5 of those, and they'll flash twice a second in a sequence to present that motion towards the runway. In order for my system to work, the ground personnel will first have to place the unit in air-to-ground control mode. This is done through the FAA type EET4833 interface unit. You'll enter a code and it'll put it into air-ground mode. And of course, if you're using that system, the Mauser control box will have to be placed in auto also. For the pilot to activate the Mauser, he will click his microphone 3, 5, or 7 times, depending on whether he wants low, high, or medium intensity. These different intensities are there so that the pilot at night, if they have them on high intensity, the lights will blind you, so you usually use low at night. But during some low visibility, you may need brighter lights, or during the daytime, you may need the high intensity in order to be able to see them at all. Once the pilot activates the Mauser, it'll remain on for 15 minutes. Now this 5 seconds in the 15-minute time, that's as per the regular FAA regulations. The block diagram, we have a receiver, a signal decoding circuit, logic circuits, and then a display circuit, a DC power supply, and a power circuit. The receiver will be attached to the antenna, or the antenna may be part of the receiver. We haven't focused on a receiver yet. But it'll have to receive frequencies from 118 to 136 megahertz. Those are the frequencies the FAA has designated for this purpose. And then it'll have to have a speaker jack or a headphone jack to attach our system to. The signal decoding circuit will take and separate the key. There's a sound. I haven't determined exactly how that's going to be, but there's a sound, there's a click at the beginning I'm going to try and focus on and separate it out from the rest of the signal. And then it'll take that, when it detects that signal, it'll send a pulse in a form that's usable by the microprocessor in the logic circuit. The logic circuit will take that pulse, it'll count the pulses and set a timer for 5 seconds. If it doesn't get the correct number of pulses in 5 seconds, then it won't come on. If it gets 3 pulses, it'll come on on low intensity. If it sees 5 pulses in that time, it'll come on medium intensity. If it sees 7 pulses in that time, it'll come on high intensity. Microprocessor will also control some LEDs for the operator for maintenance use, and then a small display that'll show the timer information. It'll also control the output relays that will tell the Mauser system to come on low, medium, or high. There'll be a display circuit, like I say, that'll have the LEDs for displaying the count, and then LEDs for low, medium, and high operation, and then a LCD display for seconds information. We'll need a DC power supply in order to power our logic circuits and the other parts. It'll be 12. I might need 2. I'm thinking I need about a 12 volt DC system for the logic circuits, and I may need a 24 volt DC for the relays. I'll have to see what I can come up with on that. The power circuit is basically going to be 2 inputs, a line 1 and a neutral, that'll provide the 120 volts AC for my system. This will come from the Mauser unit itself, and then it'll take that 120 volts and send it through the relays for low, medium, and high control operation for the Mauser system. That is all I have for today. I'm in the process of getting with the FAA engineers. I'm having a little trouble finding somebody to talk to, but it will happen, and I look forward to seeing you to the conclusion of this. Thank you.